It's my pleasure meeting you.
You're highly welcome, sir.
Okay, yeah. I don't know. As of yesterday, I made. Uh, am I? Before I proceed, is my? Can you hear my voice?
Yes, your voice is loud and clear.
Okay, thank you. Okay. I made a roll call kind of yesterday, and I was able to get like 4 people. So
Yes.
I don't know if we should. This is 5 minutes. We've already used 5 minutes already. Maybe we can wait for like another 5 minutes, at exactly 5:10. Then we can
Okay.
start what we want to start.
No problem. I'm okay with that.
Yeah, thank you. Thank you so much. Okay. Yeah, you're welcome back. So it's already time, so I think it's best we start. Others we watch the recording. Hello, can you hear me?
Yeah, I'm hearing you, sir.
Okay, thank you. Um, I don't know if you are. Can you see? I'm trying to share my screen.
Yeah, I do.
Can you see my screen?
Yeah, I saw it, but it went off just now.
Okay. Few minutes, please. Don't know why it's not sharing. Okay, let me try another. method.
Okay.
What of
It's
now?
fast now. Yeah, it's showing now.
Okay, good. It's my pleasure meeting you. My name is AbdulMalik Halaude. So I'll be the
Okay.
course instructor. So we'll be
Yes.
running through structural design. Basically, I was thinking of the reason why I asked for the details of the participants was to know the level. And from what I've gathered, I can see most of them are above 400 level. 400 level was the minimum. So with
Yeah.
that, I can say every one of us has, I can assume, let me just assume that the concept of manual calculation, we have what experience about it. Like we have the
Yes.
basic requisite experience about manual calculation. So
Yeah.
I won't waste much time on that. So we'll be, as I've highlighted in the course outline, so we're moving with that. So we're going to treat general arrangement today. Then next week, we are going to move to modeling of structure. We are going to have our
Okay.
projects. We already have a project that we are going to work on throughout this project. And
Oh,
also, depending on the number of available participants, I have some other projects too that I thought, okay, we can have it as a group or we have it as individual, depending on the number of people that we have. So with what we have at hand now, it will likely going to be individual projects. So if at the end of the day we have more people, we see how we can shuffle it. So that's that on that. So before
okay.
I proceed, I would like to know if you can make a brief um, introduction of yourself, what you know about structural engineering or perhaps structural design. So from there we can now move on.
Okay. Thank you very much. Shuaib Yusuf Odoma. I'm actually a graduate from Abaka Tafawa Balewa University. So I've been in the field for a while. But after graduation, I've actually not have enough work to do with kind of getting details of structures to translate on site that much, as in the real deal. So I have a bit of experience. I just want to add more of it more because learning is never an ending adventure.
Right? Okay, it's my pleasure meeting you. So are you currently practicing engineering, like civil engineering to be precise?
Yes, I do a lot of design by myself. I
Okay,
do, and I kind of not I've not really want to attempt into structural design yet because I still need mentoring.
okay,
So I feel I need practical mentoring first before I really take it up.
okay.
So I do a lot of I can carry out building designs and everything, bring out the structure up. I make use of AutoCAD.
Okay, that's what I want to know. I'm glad you use AutoCAD because for our drafting, we are going to be using AutoCAD. Then we're going to use Start Pro and Data Structure software for analysis and design. Okay, okay, let's proceed. The this course, the aim of this course is just to bridge the gap of having software using the user. This word is what I've learned from probably when I was in school. I first heard it. I was like, what's the meaning when the software is using the user? And it ought to be the way around. Well, what that really means is because people go to YouTube, you will attend what's it called? Various courses. They attend various courses and they know how to use softwares. But translating or interpreting or understanding what the software is giving to them and querying it, that is this really right? It becomes so difficult for them. So anything the software gives them is what they take to site. Whereas it's not always like that. There are some cases where the software, probably due to some constants that have not been input rightly or some other factors, or the programming of the software has issues or something. There might be one or two errors while running the analysis or the design. And as a result, what they have will be it would obviously be a wrong design. You understand? It would be a wrong output. So what this course is going to bridge is we're going to know how we're going to use the software, not that the software uses. It's not how we are going to query the results given to us by the software. So we are going to interpret, okay, is this right? Okay, it's right. Is this right? No, it's wrong. Okay, what are we expecting? What is expected of the software to give us? So that is the aim of this course, and I hope we'll be able to reach that level. The objective, imaginative skill of structural element assembly. What I mean by that is the general arrangement. That's the first step. We want to do your structural design. The first thing you do, okay, you've had your you have your architectural drawing with you. You have other documents such as your soil reports with you. So what is the thing? What's the first thing you do? The first thing you do is what I mean by first thing to do as regards structural design. So what you do is you do your general arrangement. General arrangement is an imaginative um, aspect of structural design because you tend to imagine, okay, if this building is like this, then how is this going to be like this? How is my column going to be? How is my beam going to be? How am I going to structure my slab? How am I going to place my shear wall to resist my lateral forces? How are all these things going to come together? You understand? That's the first thing. We're going to develop that skill, at least to a certain extent, basic skill on that. Also, we are going to integrate how manual calculation relates with software output. Okay, we understand the concept of structural analysis and design. Um, what if software analyze a simple continuous beam for us, a two span continuous beam? How is the bending force expected to be? How is the shear force expected to be? We've done all this using numerous manual calculation methods, be it moment distribution, be it moment area method, all those various methods we all know. So we are going to check, okay, we are going to integrate it that is what this software is giving us, is it relating directly with what we know from our manual calculation. Also, we are going to interpret uh, and we are going to interpret our analysis and design of the analysis and design given to us by the software. What I mean by that is, okay, we are having moments. What does that mean? We are having shear force. What does that mean? We are having deflection. The deflection is this. What does that mean on site? What does that translate to be? Okay, this end, we are saying we want to pin it. How do we pin it on site? We are saying we want to fix it. Okay, we have fixed it on the software, but how do we fix it on site? How do we know how when you get to site and you check a beam or a column? How do you know, okay, this column at the upper end and the lower end? How do you know that is rigid? How do you know it's fixed? These are some of the things that are expected of a structural engineer to be able to interpret as far as analysis and design of RCC structures are concerned. Also, on the last note, we are going to prepare and interpret structural detail. This one, I think, is more of sight. Although, as a structural designer, as a structural designer, you are meant to know how to detail. Is a compulsion. Is a compulsion. But if you go to consulting firm now, they have detailers. So what the engineers just do is, okay, the detailers have done it, so we just check it. But you as a structural engineer too, you should be able to query it. Okay, Mr. Detailer, this top bar you put here is not right. It ought to be like this. Oh, no. You have missed the shear links here. Is this thing there is a torsion bar mission. You should be able to prepare it. That's in terms of preparation. So at the tail end of this program, we are going to do slab detail, beam detail, column detail, and if time permits, I'm not sure because of the time we have, we might not be able to touch that aspect. So we are going to treat probably foundation, any of the foundation, be it pad, be it raft, or pile, or pad, or pie cap, anyone. It depends on how the thing goes. So that is that as per the overview of the course. Let's just go through basic things that we all know, that we have all known. What are the requirements when we say we want to do structural design? What are the things that are required from? Okay, we check a structural design. How do you know? How do you certify that this structural design is right? How do you certify that? Okay, it's good. The first thing that you have to consider is the safety. Is this design, is it safe? If you are living there, are you safe? Is your life safe? You know, there is this adage that says safety first is a site slogan. Let me just put it that way. It's known everywhere. Safety first. In anything you are doing as per engineering, the safety is the first thing. Then the next thing is the serviceability. Okay, this building we are designing to resist, let's say, a retaining wall that is retaining heads. Okay, if you put the soil at the back of the wall, is it going to tumble? Is the wall rigid enough, or is the wall does it have enough resisting overturning moment to overcome the overturning moment being imposed by the head? Is it going to serve the purpose at which it's being designed for? That is the next thing we should be. Okay, we have designed this building to be for cinema. Okay, if 100 people should come in, can this building can it resist the weight of 100 people? So that is what serviceability is talking about. Then the durability aspect. Okay, every structure has their own lifespan. Human being also, we all have our lifespan. When times come, everyone dies. Likewise, structure also has. The building is meant to be for certain period of time. So what are the things you consider to say, okay, this time, how is this building, how is it going to stand till that time? Okay, what are the things, have they taken the precaution, all this precaution? Is there cover? If there is fire outage, probably can this building, can it resist fire? These are some of the, is it durable enough? Can it resist the building for the lifespan specified? That is that. A design must, a good design must touch that aspect. Also, the last part is the reliability aspect. The reliability, pardon my English, the reliability aspect is the quality control and quality assurance aspect. Since you said you've worked on site before, you should know what I'm talking about. At least if you have design, and one aspect is to design, the other aspect is to ensure that, okay, is the design, have they really implemented what we have in the design on site? So that's where your quality control and quality assurance comes into play. Does the material meet the grade specified in the drawing? Do they use the right concrete grade? Is the reinforcement used? Does it have this tensile force specified in the design? Do they have cover? All these things. So it makes the design requirement. It fulfills this. It makes the design requirement fulfillment. It makes it comes into play. So that is that as per the structural design requirements. Then when we say design, we have basically two aspects of design. We have the ultimate limit state and the serviceability limit state. When we say ultimate limit state, this is the peak. Let me just say the peak. That's the right word to say, the peak. At this state, the building tends to collapse. You're going to have total collapse. That means when the building has been subjected to the maximum load inclusive of the factor of safety that have been used during the design. So that is that. Then the serviceability load, that is when the building tends to show some partial failure, but it's still fit for the service a little bit. Although it's not, to a layman, it might be unfit, but to an expert, it's still fit for the service, because there is still room for, okay, you see crack, what are the things you can see coming? Okay, let's introduce more links to it. Okay, let's increase the depth. Let's do this. If you have your column that is tending to buckle, okay, what are the things you can see? Okay, let's increase the wideness. Let's introduce retrofitting. Let's use carbon fiber reinforced polymer. Let's use jacketing. All these things. These are some of the things that come to play at the serviceability limit state. So at that state, the building is showing failure, but the failure is not total. The building is still existing, but it's already showing, okay, there are some imperfection in certain aspects of the design. Now let's move on. We have basically three types of load. We have the design load, we have the live load, and we have the accidental load. We all know all these type of loads. The dead loads is the permanent, the finishing, the block wall, the partition load. All these things are what we call as what we regard as our dead load. The fitting, the earth, and the settlement. All these are aspects. The settlement, as if you are designing the foundation, that's where that comes into play. So that is dead load. Then the live load, we have the temporary load. Those are temporary loads, like human load, like all these building accessories like chair, like bed, like other amenities. Also, we have the wind, the snow, the temperature, and the imposed load. All this comes under the subset of live load. Then we have the accidental load. These accidental load, they are short load, but when they occur, they tend to be significant. Like people that work in oil and gas industry, there is tendency of having fire outage, fire outbreak rather. A designer should consider fire load when designing structure that you know, okay, is oil and gas. Fire accidental load should be considered in that kind of aspect. Or let's say a garage where probably you have a partition wall in a garage where trailer parks or something. That kind of, you can have brake failure in car and you have impact. These are loads that does not occur every time, but when they occur, let's assume a trailer, well-loaded trailer, hit a wall, bah! It's an impact load. It's not dead, it's not live. So we have to consider, let me just say, they are special loads and they are considered at certain conditions when they are required. Then we have the load combination. When you want to take your ultimate limit state, the ultimate load, that's the ultimate limit state level. Those are the factor of safety you consider when you have your structure being exposed to dead and imposed load alone. Use 1.4 and 1.6. Now, mind you, all these conditions that I've been saying, they are according to BS code. According to Euro code, it differs. Euro code differs. There are kind of there is a little bit of adjustment in Hero code compared to the BS code. Although both are recognized, but the world is tending towards Hero code now. and probably we might review it. We might review it. But as for this course, we are going to be using BS Code because that is what is mostly used. That is still being used in Nigeria currently. Although there are some companies that they are switching into Euro Code currently. But if you go to Europe, go to other countries, advanced countries to be precise, they have neglected. Some of them have neglected the BS Code to certain extent in certain areas. They are now using Euro Code. So as Euro Code, if you have dead load and post load, like this 1.4 now, in Euro Code is not 1.4, it's 1.35. In this imposed load, in BS Code is 1.6, but in Euro Code is 1.55. Euro Code is like is an optimized BS code. Let me just say that optimized BS code. Some people will say if you tell them that okay, I use BS code, they are not economical. That BS code is not economical because just imagine if you are using let's say 5 kilonewton per meter square load and you factor it by 1.4. If you multiply 1.4 by 5, that's like what's that? I think that's 7. If I'm not mistaken, that's 7. So compare it to if you have 1.35. It's not significant. But if you have a very large load or a building that you have, let's even say that 5, but you have 20 floors. So that small magnitude times 20, that's a huge load at as a whole, if you consider the structure as a whole. So that's why some people they say, okay, BS code is not economical, so they are switching into Euro code, which I will advise you also. But for this class, we'll be using BS code. As for the loading of building, there is a code on that, BS code 6399, if I'm not mistaken, 63991. It talks about both dead load and imposed load. In fact, it talks about, there is another subsection of that code that talks about wind load, how you design wind load for your structure that are subjected to wind load. But because we will be treating a residential building, and that is what is most common, let me see, most common. I stand to be corrected. Residential, we all know the imposed load is 1.5. That's if you are considering it as a uniform distributed load, but as a concentrated load is 1.4. So yeah, you can easily go through that code. BS 6399. It has 3 subsections, 1, 2, 3. One is on load, the second is on wind, and I think the third is on roof and snow loads. That's not is not really, it does not really talk about Nigeria because I don't think Nigeria has experienced snow or something like that before. I don't know. Okay, design working life. Okay, if you design a structure, what's the expected life duration? As I've talked about earlier about durability of structure. Okay, this building is for the purpose of this building is for residential. How long is it expected to be as it has been constructed without any deformation whatsoever, be it crack, be it little deflection, without seeing anything. So a normal building should have a lifespan of 50 years. I think in Lagos now, we are even having buildings that are less than a year now, that their lifespan is already less than a year. Even while construction, we have buildings that are collapsing. So a normal building, well-designed and constructed building should last for 50 years. While monumental buildings, bridges, and other structures, special engineering structures should have a minimum lifespan of 100 years. Bridges, overhead bridges, all these what's it called? Buildings that are subjected to heavy loads, minimum years. Their minimum working life years should be 100. Should be 100 years. So we have that table: temporary structure 10 years, replaceable structures like bearing 10 to 25 years. Then agricultural and similar structures you have up to like 15 to 30 years. Then when we talk about structural materials, basically we have two structural materials that we deal with as far as structural design is concerned. We have the concrete and we have the reinforcement. Concrete differs in grades, and grade depends on the requirements or the function, the purpose of the building. For instance, now if you are constructing your pile, for you to construct, the minimum concrete grade for a pile is C30. The minimum concrete grade for areas that are exposed to chlorides, acidic substances should be minimum of C40, C30 within that range, C30, C40. The reason why we're having difference in them is because of the constituents. What makes difference in concrete is their quality, and we all know the constituent of concrete. We have the the cement, we have the sand, the cement which is the binder, we have the sand, we have the aggregate, that's the coarse and the fine aggregate, we have water, then we have admixture. That is when we are talking of a concrete design mix. Those are structures, pardon, those are concrete grade that are greater than from C30, from C30 to C40 to C45. Above, in fact, up to ultra high performance concrete now. Those are concretes that have strength as far as more than 150 megapascal. So we have different grades, and their constituent differs, as I've been mentioning. We have cement, we have aggregate, we have water, we have admixtures, we have fibers, steel fibers. That's the case of UHPC. That's ultra high performance concrete. Then we have the reinforcements too. I said my steel is very close to us. You can see normal bungalow, when they want to do normal bungalow German floor, what the mat, those are my steel. Their strength is within 250 Newton per meter square. It's not much, and their body is smooth. Those are mild steel. Then the high tension steel is what is most commonly seen around in construction sites. The minimum strength is around 460, but though for design purpose it has been reduced to 410. But now your minimum should be 410. I think Euro code also sticks to 410. I'm not so sure. Euro code also sticks to 410. Then we have the special type. The special type, when I'm talking about special type, we're talking of post-tension cables. Post-tension cable have strength as far as 1,250 Newton per meter square. If you do the tensile strength test, you have up to that. So they are for special functions. So I just tag them as special type. So that would be like the end of what I regard as like a brief introduction into what structural design is all about as for theory. We can also read up. In the course outline, I've attached a lot of additional resources there. You can get the drive. There are a lot of textbooks there that talks about concrete technology, that talks about analysis and design, that talks about materials generally, structural materials. Can you still see my screen?
Yeah, I can. I'm seeing a structural display on AutoCAD.
Yes. Thank you. So from there, I would like to back up from there, because what we have been saying since morning, they are all about theories. So we are going to work on general arrangement. So these are a structural, pardon, these are an architectural drawing that has been painstakingly drawn by an architect.
Okay.
So if you are to do your structural design, the first thing you do is you have your architectural drawing. Then the second is you do your deck study. Part of your deck study is you go to the site, you see the nature of the site, you see, okay, is this swampy? What is the water table? What are the structures that are around it? What do you have there? Okay, the government, do they have any height limitation? These are some of the things that engineers should do as far as deck study is concerned. Then the next thing is you request for the soil report. It's very, very important because soil report talks about a lot of things that you are going to incorporate into your design. Not only into the design, what's it called? Not only into the design of foundation, it also talks a little about your superstructure too. Because if your soil, if they are telling you, okay, your soil is contain little bit of acid, you should know, okay, that place, there is something wrong there. So you shouldn't be considering concrete grade less than C20 or less than C30 rather, as for the concrete grade of your superstructural element. I mean your beam, your column, and your slab shouldn't be looking at something less than C30. You understand my point? So the geotechnical report talks about a lot of things. You should check the water table. You check the nature, the concentration of water there. Is it acidic? Is it basic? What's the level of acidity? What's the level of basicity? What's the um, what's the nature? What's the soil profile? What does the soil profile says? Before you now even check the soil bearing capacity to know, okay, what's that the strength of this site, like of the soil of the site. What is it talking about? Now, let me leave that. Let's study this architectural drawing. So we have our architectural drawing now. Our architect just sent it to us. So what are the first thing you do? There are a lot of errors some architects make. Maybe while doing their some of them works, most of them works on Revit. So while exporting from Revit, they tend to have some overlay. Sometimes your grid might not work with each other. Like this grid, can you see my cursor?
Yeah, I am.
Okay. Like this grid A1 might be here, this grid line A might be here also, but the distance between AB here might not be the same as AB here.
Okay.
You understand? So it's important you check your grid line. That should be the first thing you do when you want to prepare your general arrange. So we have moved away from all those theories now. We want to start preparing our general arrangement. We want to prepare our general arrangement. This structure is a 4-bedroom flat, if I'm mistaken, and a G+1. That means we have just one floor. What are the features? We have the staircase that is going around a void. Then we have kitchen on the ground floor. We have guest room in the ground floor. We have store. We have main lodge. We have dining. We have private lodge. We have waiting room entrance. Okay. Then we have a step. So this step is telling you that your inner level have to be higher than your compound level. So that's when you are designing your foundation. So your foundation has to be higher than the compound level. That's one thing you have. This one is telling this this staircase is telling us. Okay, let's check the first floor. What does the first floor entail? We have one bedroom here. We have another bedroom here. Each of the bedroom is en suite. That means they have their personal wardrobe, water closet and shower. Then we have the master bed that has the wardrobe with jacuzzi or whatever they want to put here. Then we have the WC. Then we have the shower. Then we have a study room here. The study room has a terrace very close to it. Then we have another open terrace beside the family lodge. Then we have our staircase that is moving around and a void. Okay, so we have really studied this building. So majorly the living area, the resting area, the resting area, they are all on the upper floor, while the amenities area, maybe the cooking, the washing, everything. They have secluded all of them to be on the ground floor. So we have noted that, we've studied that. Then from this roof plan, you can see that our roof is telling us that the roof has only one side drain. It's only draining to one side. So that means if you study this roof plan very well, that means this area has to be higher than this place. This area, this front area, has to be higher than this back area. What I mean by that is, okay, when they are constructing, before they do their roofing, this area has to probably block, but I don't know, by the time we check our section, we are going to see that it has to be higher than what we have at the back. Then we check your section to see which section is this. This section XX. Section XX cut across this. It goes through the main lodge to the private lodge, and it goes through the window here. So let's see, is that really true on the section? Okay. This is the difference in level I've discussed earlier. You can see the building level. The building level is higher than the compound level. Then it goes through this wall, this first wall, and it goes through another door. Is it door? Yes, door, kind of, probably a sliding door. Okay, this is a door here. Then it cuts through, what do we have at this end? This is a window. Okay, is this true? Yeah, is not close to being true. It's not close to being true because it depends. If they like, they can do their window all the way down. So this is where you now check your window schedule. Okay, what's the name of this window? What's the size? Does it really correspond with what I have in the section? So these are some of the things you have to query the architects with on before you execute, you start your work. So also on the upper floor, what does it cut? It cuts a window that is the master bedroom window. Then it goes to another wall. Then it goes through the family lodge. Then it passes through the open terrace. Is that what we have here? Yes, I think it's almost true. We have window, then we have wall, then we have the family lodge, then we have our terrace here. Okay, that's fine. Then we check the next section, which is YY. Okay, it goes through window, bedroom, dining. So what I'm trying to say in essence is you check one by one because these details, they are very important. If you're building, if the floors are not working together, you are going to have issues when you start your general arrangement, because the first thing you are going to do as per your general arrangement is you are going to superimpose the building. And when you superimpose, it's like you are bringing the building into reality. Because that's what is going to have, that's what you're going to have in reality. The ground floor, the first floor is going to be on your ground floor, then your roof will be on your first floor. You understand? So that's where the imaginative skill that I made mention in the objective, that is where it's going to come from. Because you are going to imagine, okay, the ground floor is here. How is my first floor, how is it going to sit on it? So that is that. Then the second aspect is this section here. You can see what I've explained the other time, that the roof is one side drained. It's draining to the back, and the front is higher than the lower part. In some cases, you might even have the whole roof enclosed. That means that's what is even trending now. You have your roof totally closed, like you have wall around it. It has implication, and when we get there, I will explain. Because you can't just leave it, assuming you have a very long roof. You can't just allow your mason to prepare 7 meters wall without anything serving as lateral support to it. You understand? It's going to give off. Even normal building wall, you can't have up to that meters. Even they are going to have up to that, it has to be double. That's that. Then you check your front elevation, your elevations too, generally, the right, the left. Do they really correspond with what you have in the ground floor and first floor, then the roof? Now that is that on that. Now we've checked and we assume that they are all good. Then the next thing is you try and take off the features that are not really interesting as per structural design is concerned, as per structural features like what washing basin, this shower, this this dining table, this chair, this TV, whatever. They are none of our business. So we try. I don't always like deleting files. So what I'll do is I copy them to one other place so I can work on them and have this as backup in case I want to check any other thing. Okay, you said you use AutoCAD, right?
Yeah, I do.
Okay, thank God. Yeah, what I will do is after the training today, I will send you your own project file. You have your own full architectural drawing as mine too. So we are going to replicate whatsoever we have done today as on your own project. You understand? As time goes on, we are going to be doing it like that. So if you have any question, you can always come in because it should be interactive. Do you get the point?
Yeah, I do.
Okay, thank you. Okay, now I will make this, I will isolate this structure. I've taken off that. Then all the features that I don't like, I will prefer to take them off, select similar, and delete them off. All this kitchen, you should, if the architect have done the right thing, they should have the same layer. I take them off. This one too, I take them off. This, I select similar, take them off. This, after checking the grid by mere visualizing, you clean up your drawing. What I'm doing now is, let's say, cleaning up of drawing. All those amenities, features that are not really important. Take them off. Okay. Okay. So I think very must we clean everything, but at least we should have in drawing. Similar, select similar, select similar. Okay. To a certain extent, I've cleaned up my drawing now. So we have just wall and door. So it's similar. Fine. Okay. What I do is this. I'll highlight my ground floor. Then I'll group them. By grouping, that means I've made it a whole. If I select my ground floor, it's going to take the whole features as one, as a single entity. Then I change the color to something like green. If you like, you can change it to blue. If you like, you can change it to any color of your choice, depending. Then I do the same to my first floor too. I group it. Some people prefer to use block, but if you block your drawing, it reduces the speed, the working speed of your software. So that's why I prefer to group than to block. So if I'm working, I prefer to group than to block my drawing. So I've grouped this, then I'll give this, let's give it magenta. Magenta. So in a nutshell, anywhere we see green, that is ground floor, and anywhere we see magenta, we know it is the first floor. So the next thing is we will find a common point, which is the grid line. If the grid line is working, as I've said, the grid line is as important as anything. If the grid line is not okay, it's going to give your GA a lot of problem, because you won't be able to merge your drawings together. You won't be able to merge your maybe first or second, ground or first, any way around that you want to do it. You won't be able to match them or superimpose them together. Some people say, okay, you want to use staircase. What if the staircase is not right? The only thing that I think, based on my own experience, but based on my experience so far, the only feature that I think is far more reliable is the grid line. Aside that, some people say staircase. Staircase work sometimes too, because it's a fixed structure. Then some people use shear wall. That's if you have high-rise building or building that has lifts. So I will use grid line A1, which I believe should be A1 here also. Are you there? Can you?
Yeah, I'm here. I'm here.
Okay, thank you. Okay, now I've superimposed my drawing. So I will check round. Is my A, is it on A? Is my B, is it on B? Is my C, is it on C? Now these are overlapping. This is not a problem. But is the line of E on ground floor, is it the same? Is it parallel with 0 degrees? Let me say parallel with 0 degrees. Is it on the same line with the one on the first and are they the same? The one on the first and the second on the ground, are they the same? E is on E, D is on D, C is on C, B is on B, A is on A. 1 is also like that, 3 is like that, 4 is like that, 5 is like that, 6 is like that, 8 is like. So this building has been perfectly superimposed. So this is how the building will look like. So if you click your green, it has been highlighted. Your green is telling you, okay, this is the boundary. You can see the boundary of your ground floor. The ground floor starts here, it goes like this, goes like this. So we have cantilever here. Definitely we are going to have cantilever because your first floor surface area here is has extended beyond the boundary of your ground floor. You understand my point? So here, then we are going to have cantilever here. We're going to have cantilever here. We're going to have cantilever here. We're going to have cantilever here. Ground floor. We are going to have cantilever here too, because this terrace, this open terrace, is on the first floor. You understand my point? Also, we are going to have cantilever here. So how do we now start? The best thing, if you want to start your GA after doing your superimposition, you have superimposed your ground on your first, and if it is a structure that is more than a floor, or let's say 10 or 20-story building, how do you do it? You take your first on second, your equivalent GA, you take it to your second, then you superimpose it on your second, on your. You can hear my voice. I don't know.
I'm hearing your voice.
Okay. So if you are done with your first on ground floor, you take the GA, especially the column, you take it to your first floor, then you superimpose your second floor on it. After doing that, you check, okay, do I have to plant any column anywhere? If there is need for that, you create a beam for it on the first floor level. You understand? So that's the trend. Like you do the ground, you put your first floor on your ground floor, you generate your GA. When you are done with your GA, you take your column outline, you take it to your first floor, then you superimpose your second floor on the column and the first floor. So making three things that you are going to use for your subsequent floor. So the next floor also is going to be like that. The GA you generate for your second floor, you take the column from it with your second floor architectural layout, then you superimpose your third floor on it, on and on, on and on, on and on like that. Till 20, you continue doing it like that. That is the basic procedure on how to do general arrangement. Although, if you have 20 engineers to prepare general arrangements, none of them will have the same. It's very rare for you to have the same general arrangement because the thinking, the experience, which is one of the things that matters most as far as G is concerned, because it's not calculation. It's not something you check a textbook to say, okay, what's the formula I'm going to use here? It depends on your experience. It depends on your imagination, your imaginative skill. It depends on how you are able to play around the limit of structural elements. Okay, if I'm using 450 beam, what should be the limit? If I'm using 600 beam, what should be the limit? Although everything still goes down to experience. Now, we have superimposed our structure, first floor on the ground floor. The first thing we are going to do is we are going to create our own layer. So we have, I'll create my layer. Come on, what's this? Okay, layer. I will have a layer for beam, a beam outline. You can decide to name it beam outline if you like. I prefer to name it beam outline. Then I give it a color. Let's say yellow. Yellow is yellow really good. Let's say red. I give it red. Then I create another layer. I call that column. And I give it another color. Let's say I've used blue. I think we used blue earlier, right? We used blue and magenta, right?
Yeah.
Okay. Which color should we use now? Let's say yellow. Let's use yellow. Okay. So let's select this as our current layer and turn it off. So my layer now, the layer I'm using now is beam outline. And the reason why I like creating layer is, for ease, probably I want to do editing on beam alone. It's very important to create your layer so you can distinguish your structural elements. Probably you want to do something on certain elements, you can just easily select one and select similar and replicate for all. Or you want to take them off temporarily or permanently, or you want to do editing. It's a proper way of working. It's a proper way of working. So now let's start. This is our first floor. Our first floor is magenta. Our ground floor is green. So PL, I always prefer to use polyline. I take the outer part, I draw it. Where is the limit of my ground floor? Okay, this is the limit of my ground floor. I stop it there. Now, when it comes to sizing is also experience. Most often than not, you size your beam based on your block wall, and generally you have 225 as size of block walls. But me, I don't like using 225. Yeah, the 5 mm. The 5 mm definitely on side, it will later collapse. So I take it to 230. So I take my beam as 230, then the width, pardon, the depth based on, it can be 450, it can be 300, it can be 600, depending on the scenario. But at start, I take it at 450. So we are going to be doing 230 by 450 beam. That's what we are drawing now. Because we are drawing from plan, what we are going to be seeing now is 230. So this red line now, I will take an offset of 230, offset 230. 230 is already out. Hope I'm not too fast.
I'm with you.
Hello?
Yeah, I'm with you, sir.
Okay, hope I'm not too fast. I just want to be sure.
No, it's okay, sir.
Okay, all right. And do you have any question? Please, if you have any question, carry me along.
Okay, I will do so.
Okay, thank you. All right, then we are done with that, with this aspect. Then the next one, you draw your second. Do we have our green outline to this extent? We check. Okay, okay, it reaches there. So my beam is covered. Now the reason why we are doing GA, oh, why did I skip that? The reason why we are doing GA generally is to position our structural elements. Okay, to know where we are going to have beam and where we are going to have column. To know what will be our initial size of slab, initial size of beam, initial size of column. That's a prerequisite, like a prerequisite overview of what our structural layout is going to look like. That's what we are doing now. How we are going to ensure that our column will not be at the middle of the bedroom on the ground floor. How we are sure that, okay, the beam will not be showing in the very annoying place where the architect wants to have a space, like want to have probably a chandelier that is dropping and they don't want to see any other thing except everything going flat and you just run your beam over it. Yeah, that's a blunder. Or where your architect has specified, okay, this place should be void. So we now go and plant your column there. So that's why we are having GA. So we can have the right placement of our structural elements. Our beam will be where it ought to be, and it's going to flush with our block wall, with the architectural block wall, and our columns, most of them will ensure that they are as hidden as possible, unless we have constraints of, okay, we cannot do any other thing except to have it there. And that will be on the consensus. You have to tell your architect that, okay, young man, come here. I'm already having a beam that is spanning up to like 10 meters here. Do you want beam? No, I don't want beam. Then we have to have column here. Okay, let's have column. Okay, I will do something around it. Okay, let's have column. No, you can't have column here. I want space here. Okay, you can do your beam. Let your beam be deep. You are going to walk around the ceiling. Okay, that's fine. So that is what GA is all about. So it's more of structural placement in conjunction with architectural judgments to see, okay, is everything going to be going hand in hand? Then another terrible thing that is happening now, that is not only architect that should be involved when you are drawing your general arrangement, is the MEP. The MEP, I don't know, I don't know what I can call them. They are the most wicked, let me say, on site, they are the most wicked set of people. Because of a pipe, they can burst through your beam. And that beam might be a primary beam that is taking like 4 or 5 beams, 5 other beams. They don't care. All they know is they just want to pass their column, their pipe. So it has to be in conjunction with them also to see, okay, young man, tell me where your pipe is going to be because I'm having my beam here. and your beam cannot cut through my, your pipe should not cut through my beam, because that's one of the dangerous things. If you are having a lot of holes in your beam or structural element generally, you are subjecting that structural element to shear. There is likelihood of having crack along that path, because that's the discontinuity area, and the concentration of stress around that place might induce crack. So if by consensus, the MEP guys, they have worked around everything and they have come to you that, see, Mr. Engineer, there is nothing you can do. Our pipe has to pass through this place. Then you will now walk around your structural layout, which is your GA. You say, okay, if I want to put my beam around this, their shaft, MEP shaft, okay, let me add a factor to my shear design. So if they are passing their transverse, because it can't be longitudinal, they don't dare that. Most times it's always transverse. So if they are going to pass their pipe, burst through your beam, you've already catered for shear or anything that might happen. So these are some of the reasons why we do GA. And when you are doing it, you don't do it alone. You do it in conjunction with other people that are involved in the project. Those are the MEP, the mechanical and the electrical. The architect also, they have to be carried along to have a uniform design. And that's where all this, the new system, which is the BIM system, that's where that comes into play. I believe probably if you have the next boot camp, we can talk briefly about BIM. BIM is another thing that is solving that great time. So let's go back to where I stopped. So we have drawn, our objective is to ensure our beam are as hidden as possible. And how are they going to be hidden? Most of our beams, we are going to ensure that our beams are embedded into the block walls. So our target will be the block walls, which will be the lower floor block wall. So if you are working, if you want to prepare first floor general arrangement now, your concern should be on the ground floor layout. That's okay, where do you have block wall on the ground floor? So you can have your block wall directly on. So when they are building their block, everything can just take a flush and nothing will be showing. The aesthetics that has been proposed by the architects is going to be maintained and everybody will be at peace. And the structure will still be as stable as expected. Now, this also, I will offset it with 250, pardon, 230. That's the width of my beam. So I've drawn two beams now. So I check again. Now for a 450 beam, I always have my limits. I always ensure that minimum of 6 meters, because according to the BS code, your design, what's it called? This deflection check. If you take your element length, your structural element length to the depth ratio, the ratio for a continuous system, I think should be 26. Yes, for a continuous section, for a continuous rectangular section, it has to be 26. But for a simply supported, I think it's 20, if I'm not mistaken. So for a 450 beam, it's always advisable to limit the span of your beam, be it simply supported or continuous beam, to limit it to 5 meters, worst case scenario, 6 meters. Once it's going beyond 6 meters, there is tendency of having deflection. Okay, you understand? So, but because we are having our own beam, we have taken our proposed beam, which is our initial sizing, to be 230 by 450. So we are going to ensure that our beam, our clear span, the clear span of our beam, which is from one face of the column to another face of the column, or from one face of the support to another face of another support does not exceed 6 meters, does not exceed 6 or 5 meters. Do you understand that?
Yeah, I do.
Okay, thank you. All right. Now we check, I'll first check what's the dimension of from here to here. What do we have here? Okay, see, is 6.225. So all this is telling me is from grid line 6.225.
For the beam?
I mean the distance of grid line A to grid line C.
Okay, I see. Okay.
From grid line A to grid line C, center to center,
Okay.
effective length, which is
in
from
meters.
center, yes, is 6.225 meters. So that means if we are going to have any support for this beam, it must not be at this point. It has to be a little bit closer to grid line A. You understand my point?
Okay.
So that's the first thing that we can deduce from having 6.225 here. So let's check what is grid line C to E. Grid line C to E is telling us 5.625. So we can easily walk around this and see, okay, so that means if I shift, if I'm going to introduce column around this area, if I shift it a bit, this one will still be within this side C to E. Will still be within allowable range for a 450 deep beam, while this one will also be within the acceptable range for a 250 by 450 beam. Sorry. All right. So that's that on that. Let's continue. I want to take another length of beam because we have not started drawing column. We are just drawing beams round now currently. So this is, let me check. Where is the end point of my ground floor? Okay, my ground floor ends here. So my beam should terminate here. So let me just draw another one here, another beam here. Let me assume it's terminate here. Let me see my green. Okay, my green goes like this, it goes like this, it goes like this. But what is it supporting? What it that is our first floor. We check the limit of the first floor too. Does the first floor, does it extend to this place too? Yes. Okay, you are not seeing it very well. That's when you now call back what you have hidden earlier. That is the original architectural drawing. I called it back. 3 seconds. So I have it back. I'll check to confirm. Okay, it shoot out here. It also shoot out here. So that means there should be a slab around this place. There should be a slab around this place. So we go back to our layout. Here, draw a beam. I offset it to 30. No. Offset to 30. There's another one here. Okay. I wouldn't want to draw. There's something I want to do here. I can make this a cantilever. I take an offset here. Okay, where's the end of my ground floor? Okay, my ground floor ends here. So I can easily trim this off. So far so good. What have we done so far? Let me take this, select similar objects, there's object that I'll bring to the front. Okay, what I've done to all my beams, how many beams have I drawn so far? I've drawn this beam here all the way, all the way, all the way, but I would like to trim this. There is something I will explain on this. I will explain this later. Okay. I've not offsetted this. Let me take and offset this. Let's see. Okay. So what I'm drawing first are my perimeter beams. My perimeter beams. Offset. Come on. Select this. Take an offset again. 230. Let's offset. Then trim. All right. So we have drawn all our perimeter beams. Okay. We have drawn all our perimeter beams. So let's now walk inside. Let's walk into the building. Where do we have block wall? Where can we introduce beam? Okay. If I introduce a beam here that goes all the way, this beam will be a very good beam because we have block wall on the ground floor that goes virtually from here. It goes, we have a door here. Door, you know, before door, above your door, you have lintel. You understand? So definitely we have a beam that goes through this place. It's still going to be, it's going to flush with the block wall that will be mounted on top of the lintel. You understand? So there is no issue passing our beam all over up to this place. So I can draw one very nice beam. And draw one very nice beam from here. But check this beam. This block wall rather is likely going to be 150 because it's a partition block wall. Okay, it's 225. Good. It's 225. Good. So I take PL. I take from here, from this grid line here, 115. So this 115 gives me, and I take it all the way down. Then from here, I take an offset, 230. So I close this to meet with the other beam, meet with this beam. Okay. How many beams have we drawn so far? We've drawn the perimeter beam, right? And
Yes.
all the perimeter beams are all flushing with the green. And mind you, our green is the ground floor, right?
Yeah.
Okay, good. So, and we've divided this whole building now into two. We have this portion and we have this portion. We can't have an engineer that has mind say, okay, this building I'm done with the GA. That's one engineer I'm just saying. Let me move this guy away by let's say 50,000. I've moved. This is what we have done so far. This is the GA we've created so far. An engineer can say, oh, what a very nice slab. I've created my slab. We just say from here to here. You know, we have two types of slabs. We have one-way slab and two-way slabs. Two-way slab, rather. This is 5.6623 meters, and the other length is 13.23. Wow, this is a very nice one-way slab. So I'll just leave my, excuse me, I'll leave my GA like this. This is not an economical. It's allowed. It's allowed. To be candid, it's allowed because I think this can pass. This is 5.625. The LX of your one-way slab, this with 150 mm slab, this will pass, but it's not economical. The reason that being that if you decompose the load of this slab and you distribute it on this beam, the depth of the beam of this beam that will resist the load coming from this slab will be much. Unless if we have columns that are sufficient enough to bridge this layout. pardon, to bridge this beam. Do you get my point?
Yeah.
Into span to have a continuous beam. Unless you have that. But generally, this layout is not economical. So we have not finished our work. We have not finished our work. So we take this back. I think I took it off by 50 meters. I take it back, so it's back on it. So we continue our journey. So we check again, which other block work can I use? Okay, if I draw a line here, if I draw a beam here, does it make sense? Yes, it makes sense. In fact, it's going to work with this block wall on the first floor, because as you can see, as I'm touching the gray, the magenta color, is telling me that, okay, on top, on this same grid line 3, there is another block wall that is corresponding to this grid line that is on the ground floor, and the wall is flushing. So having a beam here is another thing we should be thinking of. So let's try and create another beam here. Where is the wall? I'll make sure, I always ensure that my beam is always at the center. The center of my beam is the same thing as the center, is flush with the center of the block wall. So if at all, if the beam will be bigger than the block wall, it's going to be of the same offset on both sides. Here, take an offset from here, 115. Okay, draw it. Take an offset, 30. Right. Extend it to this beam. Okay, that's fine. That's extended. Moreover, if you check this first floor, you can see that this beam, can you see my cursor?
Yeah.
Okay. If we are going to plant anything inside this wall, inside this wall on the ground floor, it will not go beyond the ground floor. Why? Because on the first floor, this wall is beneath the slab. It's not directly on, it's not flushing with the first floor block wall. So anything that we are going to have, be it column, that's in terms of, I'm saying column, if we are going to have any column along this block wall, is going to terminate on the ground floor. It cannot extend. So in a nutshell, what I'm trying to say is, this beam that we are going to introduce, it is best that we extend it to go beyond this end, to go beyond the first beam, this beam that we have drawn, because later you can plant a column on it to go and to support the roof, or perhaps let's say we have other floors above. I'm just assuming. If you have, let's say this architectural drawing is not a floor, it's probably 2 floors. So it's advisable you extend this your what's it called, your beam, to extend it to have like a cantilever beam to the boundary of your first floor. So that's what we are going to do here. So I will leave this, I will not trim it. I will come here also. I will see what I can do here later. Okay, do we have something nice here now? Let's measure from here to here. What do we have? 6.22. That's what we measured earlier. Then the short span, what's it telling us? The short span is 3.825. So this is a very nice slab. So we have a complete slab here already. It's a very nice slab. Our slab here is 6.225 by 3.825. If you do your Ly over Lx, I think that should be it should be around, it should close to be one-way slab. So it's not too bad. It's not too bad. So we can leave that like that. Then another thing we need to consider here is Then we move to the next part. Where is this green? We click on the green again. Okay, this beam that we drew earlier, the beam we drew earlier, can we extend it to meet this beam here? No. Why? Because there is a staircase here. You can't have your beam.
Yes,
Yes, exactly. So it's going to intercept with the staircase. So this beam will not go beyond this place. We leave it here. So we tend to walk around something around this place to see what we can formulate around this place. Then we click on our green line again and see where we can draw our beam. Okay, the staircase is here, but there is a block wall next to it. Can we make use of that block wall? Yes. In fact, that block wall is like the block wall we saw here. It's also flushing with what we have on the first floor. So we can easily draw our beam. And as I said, I don't like, okay, let me take the extreme end of my first floor as my reference, of my first floor, because the beam should not shoot out beyond what the architect have specified. So I will draw my beam, I will go and meet this. It will meet this guy here. And I'll take an offset of 230. Offset 230, 230, offset. So we have drawn the beam. Is there any question so far?
This offset of 230, it doesn't tally with what the architecture has done with 225. Wouldn't there be more? Yes, wouldn't there be interference in his own work?
No. The reason why I'm saying that is, after they have done, what's the difference? The difference is 5 mm.
5 mm, yeah.
Yes. The 5 mm is nothing. It's something plaster when they are doing their finishing. In fact, sometimes on site, by the time they do their block wall, the block wall even go beyond the beam itself. So the plaster will cover it. Is still within the range. 5 mm is not much.
Okay.
Thank you for that question. Thank you. That shows you are following. Thank you. Yeah. Okay, we've created another floor here. Another panel of slab here. Let's see what does that slab looks like. It starts here. It goes all the way like this. It goes all the way like this. Goes all the way like this. Okay, we're almost done with this part. Okay, but this beam is going to be showing on the ground floor. Do you get what I'm saying here? Because there is no block wall here. What are we going to do? We leave it like that. Because obviously you can't have 100% what's it called? Every time you give your architect preference, there are some cases. This case, you don't consider, okay, if there is block wall or not. This beam that you have drawn, you need to support it. And I want to use this beam that I've drawn here to support this beam that I've drawn here. I don't know if you understand what I've said. Hello, are you there?
I didn't really get the idea of using the other beam to support the other one you drew down.
Okay. There are varieties of ways of creating system, of creating supporting system for beam in a layout. It's either you use column to support a column, to support a beam, or you use a beam to support another beam.
Okay.
And the beam that is supporting another beam will be a primary beam, while the supported beam will be a secondary beam. So what I've said now is I would prefer to make this beam, this beam that I'm touching, that I've highlighted, I'll prefer that it's become a secondary beam on this beam. So in a nutshell, on site, what they are going to do is the reinforcement coming from this beam is going to sit on top. It's going to be on top, the bottom reinforcement of this beam. If at all we do not make any adjustment as far as this layout is concerned. What I mean by a beam supporting another beam, that's what I'm explaining now. So that means the reinforcement of this beam is going to be on top of the reinforcement of this beam.
Okay.
So when the iron benders are working, these are some of the things as a designer. This is what you check. Okay, are they not putting the reinforcement of this beam on top of this reinforcement? That means they have changed the support system. Do you understand? So that means they are making this beam a cantilever now, and they are making this beam to be to have unnecessary support. You understand my point? So that means this beam will not be stable again. So that's what I'm talking about. So we have primary beam and secondary beam. It's not every time you introduce column to support beam, you can introduce another beam to support another beam.
Okay.
Yeah. So that is that. We are done with this one. Then let me complete this upper face. Let me just complete this upper face. Okay, what can we do here? What can we do? Mind you, this magenta line that I've highlighted, it is on it that our roof is going to sit on. So definitely we have to have, probably at each of the edges or very close to the edges, we should have columns that will go up to support the roof beam also. So in that regard, I will prefer to extend either of this beam that I've highlighted, or this beam. If it is this beam that I'm picking, I will extend it to protrude out to meet this point. If it is this guy that I'm choosing, I will extend it to hit this guy. Hello, are you following?
Yeah, I'm following.
Okay, thank you. So I will extend it to hit this guy, so we can have like a cantilever beam, and it's going to show on the ground floor. But it's not a problem. I know I will talk about how we are going to solve that. Now, how do we now determine which one are we going to extend? Now, this is how to determine it. What's the length of this beam? The length of this beam, what's the length of this beam? Obviously, without even measuring, by mere eye inspection, this side is longer than this side. I stand to be corrected. I think I'm right?
Yeah, it's rectangular in shape. So
Yes, so this side is longer. So the longer side will tend to have more load, and is going to have more moment. As a result of more load, it's going to have more moment than the other one. So breaking this panel, breaking the length of the beam here is advisable than having it being extended. So in that regard, I will take this as preference. I will extend this. I will extend this too. Do you get what I've said now?
yeah.
So with that, if I'm going to introduce a beam along this path, the beam will not be as long as this one. So with that, I'm having an economical design. I've reduced the
That
load.
means you have lever situation there now.
Pardon? Yes.
Lever situation there now.
Yes. I'm having a cantilever beam here and a cantilever beam here.
Okay.
So now what are we going to do? Then I will draw the beam. The beam I've been saying since morning. I will draw the beam. I will draw it. Meet this. Then I'll take an offset of 220. Now with this beam now, what is happening? I will take another one. Okay. Okay. Yes. I will take an offset 230. Okay, that's fine. Then now, this beam that I've drawn here, let me start from here. This beam that I've drawn here, is it going to have support? Yes. How is it going to be supported? This beam is shooting out as a cantilever. We can use it to pick this beam. So which one is going to be the primary? Is it the one on the horizontal or the vertical? Here. Can you hear me?
Yeah, I'm hearing you, sir.
Yeah. I asked a question.
Okay. You said the one that will be the the primary beam.
Yes.
The
I've drawn two beams now. There
yeah.
is this beam, the one, and there is another beam here. I said this beam is going to be a cantilever and is shooting out by this length from here to here. But this beam is going to be from here to here. But we are still having another beam that is coming out to pick it up from here, which is also having the same length of cantilever as what we have at the lower section here, at the lower part of the building here. So my question now is, at this edge, at this corner, and at this corner, which beam? Is it this beam that is primary or this beam that is primary? Which one? Is it the vertical or the horizontal?
The horizontal should be.
Horizontal, yes. The horizontal is. Although it's a cantilever beam, but it's going to be doing the work of a primary beam also. As in support system, it's going to be a cantilever in a support system. Yes, it's going to be a cantilever beam, but it's also going to serve as a primary beam for this beam that is running all the way up here. So now I've drawn this. Now what I'm proposing now is I want this beam that we have used these two cantilever to support to be a support for this beam also. So that means this beam that I've highlighted, is going to be supported here. It's also going to be supported here. But at the end here is going to be a cantilever. What I mean by a cantilever is it's going to be the support for this shorter beam. You know, that was the aim. That was what we checked the other time, that okay, which side is longer? Is it this side that is longer or this side? And we realized that this is actually shorter than this. So we gave preference to this to break the span. So now we are using this as our being the short span. We are going to make it a simply supported beam, and it's going to be supported with this beam that has been supported by the two beams that has cantilevered out. You understand my point?
Yeah.
Okay, thank you. Now, how do you now support this beam at the other hand? Then I introduce another beam. Now, I can say I will terminate this beam here. Take an offset. 230. Do I really need this beam? I don't think there is a need for this beam here. I'm thinking the other way around. Okay, there is need because we are still going to plant a column on it.
Yeah.
To support the roof beam, as I've said. Because someone will just be thinking, please don't be like people. I don't know. There are some engineers that plant column on slab.
Okay. Well, which is not
yes, it's not ideal. It's not ideal. There is high tendency of having punching, and the possibility of having punching in that area. And I'm sure they don't design those slabs. They don't provide punching reinforcement for it. Is very, 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 very dangerous. So I will advise that if at all we are going to have a beam at the end, and probably you are seeing it as being sitting on the slab, please don't see it as that. See it as okay, I need to provide a beam to carry it. You understand my point? Yes. Now, I've created a short beam here. My mind is telling me that this short beam is a cantilever beam, but why can't I make it a continuous beam? So it's going to be a two-span beam. This beam. This beam that I've highlighted, I can actually have it as a continuous beam. So in that regard, I'll have something like this. and also have something like this. Our time has been far spent. Oh my God. Okay, we have two classes for this. We have two classes for each of the sections. So anywhere we're able to reach, we continue from the next class. But I want us to finish this part. So we have something so rigid. So we know is the lower part that will face the following class. Okay, where is the second one here? Other link points. Okay, it has gone off. All right. So now what's the support system? How are we going to support this now? I've created a beam here. This beam is 2 span. It's continuous. One end is cantilever. It's going to pick this beam. It's going to support this beam. This beam has been proposed to be simply supported. Proposed because we don't know. Probably if we open it up, what we can see. Probably we can still walk around it. That's that. So we are done. I can say we are done with this part. We have supported virtually everything here. We have supported everything virtually here. We have created beams round. Now here also, let's check, is this beam, is it enough? Is it really enough? Yes, it's enough. But as we have said here, this first floor has extended beyond the boundary of the ground floor here. So we need to introduce a beam so that later we are doing our roof floor layout, we can plant our column on it. So we introduce our beam. Our beam starts from the boundary of our first floor, then we hit it to this beam. Offset. We take an offset, 30. Are you with me?
Yeah.
Okay, thank you. So yeah, I think this guy is looking like a box, unlike the case we have here. Or am I the one? This is also rectangular. Let's confirm. This is 3 points. This is 4.2, 4.42. Here live. This is 3 points. Okay. This side is longer than this, it's rectangular. This side is longer than this. So which one are we going to give preference from what we have done at that other side now? This longer side. Longer side. Thank you for that. So we are going to extend this beam. We're going to extend this beam too. So if we extend this beam, so that means we are going to create another beam here. Pick up the one we want to make a simply supported beam. Offset 30, 30. Line. An offset 30. Now I can say we have done to a certain extent, we've done a reasonable job here. Is it reasonable? Let's check. Let's take this off like 5,000 meters. Taking it off. Wow. See what we have created. Now, as I'm seeing it, I don't know if you're also seeing it like that. I'm thinking we can pick up this beam.
That particular one?
Yes.
Yeah. We are over reinforcing that area then.
Yes. We can actually rip off this place and have something like this.
But it all depends on if we are going to have from that extension upward anyway.
Which one? You know, I told you. Let me bring back the 50,000. Let me bring back the layout. You can see it's a very easy touch on site. What they will do is we will make this all place a slab, they will just build their block wall to hit the slab here
Yeah, it
on the
stops
ground
there.
floor, and it stops there. Then we have our first floor shooting out. You understand my point?
I don't understand that. So no,
Yes.
no, it's not.
Yes, that beam is not important. So that's what GA is all about. An engineer can decide to retain it. You know, there is no what's it called? You don't have to question it. But that design, it will not be economical. You understand? Because just imagine the cost of constructing this beam from here to here. The concrete, the additional concrete that will be added to the slab, the reinforcement, the workmanship, the time, the form work, the losing, everything. You understand? Here also, I think we can do the same thing. This place also is looking like the same. But can we remove this beam?
That one entirely.
Yes. No, like, you know, we reduce this
Yeah,
beam.
yes, that section in that.
This one? You mean this one?
Who made that one the primary? That one is the primary beam, I believe.
Thank you very much. Thank you very much. You dare not remove this because the primary beam is the one supporting this beam. That's what I want to hear. You dare not support, you dare not remove it. So that's the same thing we are going to do here. So which one are we going to reduce here now? Is it the vertical base or the the horizontal beam or the vertical beam? Which one?
Vertical.
The vertical. No, it's not the vertical. The vertical is the primary. This is the vertical.
Because it's also extending downward.
Exactly. So we are going to reduce this. We are going to reduce this. You understand? Okay. I, as a person, I want to take off this. Let me hide it. Oh, don't let me hide it. Let me just. Yes, I want to take off this. Is it allowed?
Not allowed because you still have the roof.
I can take it off now. Okay, let me bring back my layout. I'm coming. M50,000.
You know, we have columns there.
What if I plant my column on this beam here? I'll plant one here and plant the other one here. It's going to be stable. This beam has nothing to do with the column. In fact, it's going to be additional punch load, yes, on this cantilever beam. I don't know if you understand what I'm saying. Do you get my point?
Yeah. Okay. That particular section is even at the first floor.
Yes. This is on the first floor. This is the first floor. This is the first floor.
Load is from the ground floor there.
Exactly. Exactly. So, but I, as a person, I would prefer to return it. You know why? Aesthetically, seeing a beam shooting out, another beam shooting out, then we now see a slab. Then it now look like letter U, inverted U. I don't know if you get what I'm saying. I always like to enclose. It's like finishing your work. You close it up. Even if it is, you can reduce the thickness of this beam, to say, let's say 200 or even 150. You understand? I mean this beam.
Okay.
You understand my point?
Okay.
Since it's not going to do anything substantial. In fact, it's another load, as I've said. I can just have, I'm coming on. I want to take it off by, let's say 5,000. I take this one off by 5,000. Okay. If I draw just a line here, if I draw just a line here, I draw it and it stops here. You know, this will be a slab. If I cut a section, if I cut my section like this, what am I going to see? Come on. I'm going to see, come on. 450 beam, 450 beam. Then what? Then this length. Oh, God. Okay, I'm coming. Let me draw it from here. 450 beam. Then stops here. Then I'll 150. Then This is what if I cut a section, this is what I'm going to have. Hello? Are you following me? But if I'm going to introduce this beam here, I will not have just ordinary slab here. What I'll be having here is going to be a slab. It's going to be a beam rather. Offset 230. This is what I'm going to have there.
Okay.
Which will look nice. So if you are looking, let's say if I'm standing here after the completion of the project, I will not be seeing one ambiguous shape. If I'm standing here, where my line is. Let's say I'm standing here and I'm looking directly in this direction. I'm looking like this. I'm looking towards this place. What I'm going to see is going to be something like this. 450. Let's assume this is the length of this. The length of this slab is up to this. I hate this shape. No, mind. I'm so sorry to say. I don't like it.
Is it no more like referring to an overhanging beam situation? Is it not?
Yeah.
Like when you have the projection is overhanging, right?
No. That's what I'm saying. Like, if we finish your build, okay, let me say, okay, I'm coming. Where is the side view? Where is this view? I'm coming. Where is this view? It's here. Okay, open terrace. We have open terrace at the top. Okay, I think it should be this place. This is the place I'm talking about. You can see we have, this is where we have the cantilever. The cantilever we are talking about. You know what we are going to have here? If we do it like that, we are going to have this one offset 225. Then we are going to have one that beam, the other beam here, drop by 300 because that will be the base of the slab. Then we have 230. This one also. This is what we are going to have. You understand? But if I have a beam that is closing this thing up, I won't be having something. I will just have something like this. I'm coming over. Okay, let me. We just have like an extension of this. If this one has been extended down.
Which
You
gives
understand my
it,
point? Yes. So everything just look aesthetically, to be aesthetically pleasing. You understand my point? There are a lot of buildings that people do like that, but I don't know. The engineer, even if it is just 230 or 150 beam, just put it here to have a better what was it called on that place at that place. You understand my point now? Do you understand my illustration now? Yeah, thank you. Okay, so on that note, I will keep my beam 5,000. Please pardon me. I took 10 minutes the other time. I will take my 10 minutes back. I'm sorry.
No problem.
Please pardon me for that. So if you like, you can say, okay, I will retain this as 230. And if you like, you can retain it as 150. It's not a problem. Since it's not doing anything so serious, it's just to protect the aesthetics there. You understand my point? And the column you are going to plant is not going to be reacting on it. It's going to reacting on the one that is coming out to pick the beam itself. You understand my point? So far, what have we done? Let's see what we have done. 5,000, 50,000 rather. Okay, we have not introduced any column. but at least we know where we are going to put column. They are already showing up. Our slabs are coming up. We know we have slab here. We have slab, we have slab, we have slab, we have slab, we have cantilever, then the lower part. 50,000 is much. 50,000. Okay, so we are done with that aspect. With that side, we are done. So now let's try and take off the void the architect said he wants. What the architect says is, okay, this place, so I don't want anything. I want people from up to be seeing people down. That is what this guy is telling us here. And it's not a problem. We are going to do it. So you're taking that off. Okay. Nope, not like that. The whole of this place will be a general void. Now let's study our staircase. It's important we study our staircase to know where we are going to put our void. Where does the staircase stops on the first floor? What is this? Is this on the first floor? Yes, it's on the first floor. Let's check first floor, this first floor. What is this? Is this really possible? Are you seeing what I'm saying?
Yeah.
Is this really possible?
Let's use the section to view.
Thank you very much. That's what I want to hear. When we go to our section XX. From section XX, we can actually read up from section, although there is no section that goes through it, but most of the section are facing it. So section XX, let's see. XX is this. XX is telling us that that long side is the one going up, and there is no wall that is hitting it.
Okay.
You understand? So that means this is an architectural error. This is an error. I said architecture, probably export error from the architect. Why doing export? Because you can't have a wall that will shoot into your staircase. In fact, this from the section, there is nothing like that. You understand my point? There is nothing like that here. The staircase moves on its own, and this is on the ground floor. This is the one that is leading directly, that is hitting the first floor slab. And the last step flush with this block wall, with the block wall of this bedroom. You understand my point? So I can actually introduce a beam, and that beam is going to serve a lot of purpose. So this is where we are talking about. So this staircase actually did not reach this place. Abi, let's see, let's pick. We have 3 more minutes, and then once it's time, I will drop. Okay. We have this is where the what they called is. So we can actually introduce a beam. The beam will start here, go all the way. I'll just leave it tentatively here because I know later we are going to have a beam that is going to reduce this span. You understand my point? So we take an offset 225, 250. I said 230 rather. 230. I've taken the offset already. Now let's see the ground floor. Which other wall can we utilize? Okay, a very good wall is there. A very good wall is there. You can actually utilize this wall. So let's pick. What is there safe? Why is this so open like this? You go to your ground floor, you check. Oh, it's a private lodge. And the private lodge is next to the dining room. So this is like a porch. So it's not a problem. We can easily pass our beam on it. They can even do like a porch design here. You understand my point? And put probably a curtain or something, whatsoever they want here. depending on the choice of the interior designer. We can have, let's take a beam. Okay. 115. What's that? I have 1 more minute. After drawing this beam, we'll call it a day. And I stop it here. I take an offset. 30. Okay, then. So now, before we go, take a look at this junction. Which one do you think will be primary? Which one will be secondary? Is it the horizontal that will be primary or the vertical?
The horizontal is longer.
The horizontal is longer? Okay, so it's going to be the primary, right? You mean this one, right? No. Yes, you are right. It might be longer, but you now look at the support system. Now, if we make it this one, please. This last explanation, I'm sorry. This last explanation is already 10. This last explanation. If we are taking this guy as the secondary beam, what does that mean? What's the implication on this beam? That means this beam will be a cantilever, which is statically unstable. Statistically, analytically unstable, rather. Analytically, it will be unstable. So in that regard, we are going to make this horizontal beam the primary, while the vertical will be the secondary. Do you understand? So I will stop from there. By next class, we are going to continue here. But as because I don't want the project to go, I want it to be individual projects. I will send your project to you before the end of today. You have it, your own personal project. So I will want you to start something on it, and if you have any problem with it, you can always share it with me. You send me probably a screenshot, or you message me. I will respond to it once I see your message. Once I see it, and I not be online, but just leave it. You can leave it as inbox on Discord. I will respond to it. We take it up from there. So our next class is going to be on Tuesday. It's going to be on Tuesday. We are meant to have a class on Saturday, but I won't be available on Saturday. So we are going to have our class on Tuesday. Our next class is going to be on Tuesday.
What time is that?
The normal class, that will be on 1 to 3 on Tuesday. Normal time on Tuesday, 1 to 3. So we are going to start from where we stopped here now. All right. Thank you so much for joining. It's my pleasure meeting you. I'm so glad that you followed the training.
Thank you very much.
Yeah, it's my pleasure. Do you have any question so far?
Not now. I will just go through it. I'll go through the YouTube and assimilate more.
Okay. And if perhaps during the reviewing, if you have any question as per what I've said or something, or you didn't get anything right, you can always message me. And the material I added to the what's it called? The course outline. They are very, very important materials. You can also access them. You can go through them. The decode has a lot of YouTube videos. The instructor.com is a very good website that you can get a lot of information from. And the drive has a lot of text that are always helpful. Also, I think I added one other textbook or something. So that's that. Yeah. So we call it a day from here. So meet you on Thursday.
Tuesday.
Pardon, on Tuesday. Thank you. Yeah. All right.
Very much.